So sorry for this disruption, but we carry on with our explanation. So we have been talking about the difference between project management and systems engineering, and we talked about time and scope management, cost management, quality management. This is the focus of project management, but also we talked about requirements management and performance and technical risk. And we talked about the example of a tower that has a mall and it's connected to a metro station. So now we need to change the requirements of doors and the requirements for elevators. A project manager would be thinking about what would be this change will introduce to the time delivery of the project, to the schedule, what would be the added cost, and at what quality. So this is what a project manager would be thinking about. And now this tower, while a systems engineer will be thinking about those new requirements for these doors that is added through the design or the change of the design, what they will have on the performance of the project, what would of the tower, what impact they will have on the what risk they will have. So for example, if you have people going through your mall and moving to take to the metro station or to use the shopping mall, the change of requirements for doors and elevators will affect the speed of movement, and this will affect the performance of your structure. So this is just an example of what a project manager will be focusing on and what a systems engineer will be focusing on. And it's good to understand the roles. The roles, you have a client role, for example, as the systems engineer or the project manager might play a client role trying to push the requirements to the greatest level of quality to try to get the best things the best thing that can be done. Through contracts also can be managed through a contract manager role. A project manager, you can play that project manager role focusing on cost, quality, and time. And the systems engineer role, you can focus on performance, on technical risk, and on requirements. So performance is a big thing and understanding the requirements is a big thing in systems engineering. And this process actually happens at different stages in every project. So now there is a well-established processes that is being used to track the systems engineering process as well as the project management process in different stages of the project. So there is a design stage, a management stage, a build stage, operation stage, ownership, maintenance, and finance. And just to try to capture those, there is a network rail process that is called GRIB. And GRIB is a way for classifying the stages of the project from inception to completion. So if you have a GRIB 1, then you are in output definition. You are still trying to define what is your project going to be. If you are on a GRIB 2, you are on a pre-feasibility study. If you are in a GRIB 3, you are trying to choose what options you would consider for this project. If you are in GRIB 4, you would take a single option. If you are in GRIB 5, you will take a detailed design. If you are in GRIB 6, you would do construction, testing, and commissioning. If you are in GRIB 7, you will do scheme handback. And if you are GRIB 8, you will do a project closeout. So this is how this different stages of the projects happen, and you can capture those on in what's called the GRIB process, just to define at what stage is your project, and every stage you can apply the project management principles and the systems engineering principles of this process and making sure it can take you to the next one. So just another illustration, you would be thinking in stage 1, like identify, 2, high-level definition, 3, detailed definition, 4, design, 5, delivery, 6, demonstration, and 7, close. So finally, we stop with requirements and scope management. So project fails in many occasions because of the following. Either they fail to meet the client's needs or expectations, they are late on delivery, or they are over budget. So if the project is over budget, we say this project is a failure. If the project was late on delivery, we say this project is a failure. If the project failed to meet the client needs, we say this project is a failure. So because we don't like to fail, we like to succeed, we have to capture requirements in the right way. And capturing requirements and communicating them is one of the fundamental ways to achieve success in projects. So requirements play a central role in capturing and communicating the contract and the client needs. So a good requirement is just how requirement should be: correct, clear, focused, precise, and ambiguous, self-consistent, usable, singular, traceable, verifiable. And just to summarize those 10 features in 3, they should be measurable, they should be achievable, and they should be testable. And you can collect them from gathering functional specifications. Of course, you can collect requirements from so many sources, from the client's needs, client's meetings, functional specification, system definition specification, technical workshops, and other meetings, to try to capture them in one place and collect them and make sure you trace them until they are delivered. This was a quick introduction about the difference between a project management approach and a systems engineering approach. And I hope you have a great understanding. Systems engineering is much more suitable for large projects, large and complex projects. Project management is definitely suitable for smaller projects that can take less time and maybe less cost and have a less complexity. Have a great evening, and we'll see you in the next lesson.